All right, there we go. So we've got a warm up on the board. We've got x squared plus x plus 42 is equal to 0. So
Minus 42.
whoa. Okay, so we want to solve this, correct?
Yeah.
Oh, it's minus. Oh, sorry. Wow. Okay. How could we solve this?
Factor it.
We could factor it. Do we know how to factor this? We forgot. Great. For those of you who are kind of working on this, what's a technique that we can take a look at for factoring? Okay, when my x is equal to 0, and if I'm factoring, I might be looking at this constant term, right? So is the constant term positive or negative? Negative. So what does that mean about my factors? One is plus and one is negative, or minus. Subtraction, addition, you know. Okay? And then what's the next part of the strategy that we talked about last week? Factor pairs. Right? So how would I break down 42? 142, 221, 314, 6 and 7. Is that it? Okay. So what pair could I use where one is positive, one is negative, and it add up to a positive one? Okay, 6 and 7. So which one's positive and which one's negative?
7 is positive.
All right. So then I have with the zero product property now, right? So either x plus 7 is 0 or x minus 6 is 0. Does that make sense? We're gonna, right? So here x is negative 7 or x is 6. Now, Josh, you're asking about 7 and 6 here. If I multiply them back out, maybe you use this model, maybe you use FOIL. I have x squared, 6x, 7x, 42, so that's going to give me, oh, and this is a negative 6x, right? Because this should be minus, and negative 42. Okay? Do you see what I did there, Josh? Okay, so I know it's x plus 7 and x minus 6. I'm multiplying them together. Okay, so x and x is x squared, x and 7x is 7x, negative 6x and x is negative 6x, and negative 6 and and 7 is negative 42. And I'm doing that to check my factors. Okay, because the goal is to get back to this original. Why is it 6 and 7? Okay, so you know how 6 and 7 is the 42 I want, right? I want that middle term to just be x. So the negative 6x and the positive 7x will give me the x that I need for the middle term. Does that help? Okay. So I get x is equal to negative 7 and x is equal to 6. Are we okay with that? Okay. Yeah, what's your question? So do you know how, like, if a times b equals 0, either a is 0 or b is 0, right? Yes. Okay, so the 7 has to be the positive one because I want a positive x in the middle. If it was negative, I'd have a negative x in the middle. Does that make sense? So the adding makes a big difference. All right, now we're going to have another technique for checking this. I don't think this is actually going to show up on the screen for the video, but you guys should be able to see it. We're going to graph this. Okay, so y equals x squared plus x minus 42, right? Okay. Now look at where it intersects. It's intersect here at 6 and negative 7. Notice that matches my solutions. 6 and negative 7. Does that make sense? Okay, so now we have two ways to go about solving an equation that looks like this. Okay, today where we're going is we're going to introduce we're going to be introducing a third technique. Okay, The third technique we're going to be talking about is completing the square. Now, for those of you who got started ahead on the computers on Friday, you might have already started something on completing the square, but maybe it was a little tricky, maybe the videos didn't make sense. I got some feedback that that topic was a little more difficult. So what I want to do is I want to show you some of my thoughts behind it and give you an example, and then we can kind of write out what those steps look like for us, just because it can be a little more tricky. Okay? So taking a look at this, the basic gist of completing the square is you're trying to get it in this particular format. Okay? X plus or minus a number in parentheses squared is equal to a number. Okay? Does that make any sort of sense? Okay. This is like the generic form we're going for, because basically where we can go, because we have this format, is I can take the square root of both sides, and then x minus a is equal to the positive root, or x minus a is going to be equal to the negative root, and then I can have my two solutions come from there. That's like the overall reason we use this strategy. Does that make sense? Right, basically it allows it gets it set up so I can take the square root of both sides and solve from that point. Okay, so could I solve like the same problem using graphing or factoring or this third technique? Yeah, and you're going to get the same answer no matter what technique you use. Does that make sense? You want to do an example? Okay. So the example that I pulled for you guys today, I picked some with like bigger numbers. I also picked some that don't have fractions. You can have fractions. Okay. But we're taking a look at right now x squared plus 12x plus 32 is equal to 0. Okay. Now I don't know what you want to call this step, but the first thing I do is I get myself set up to actually go through this process. And the way that I set it up is I have everything with an x on the left, and then all the numbers on the right. And I leave myself a little bit of space after each one. Okay, so does everybody see how I, for some reason I don't like the way that was written, how I moved the 32 over and made it negative? Any questions on what I just did? Yeah, all I did was subtract 32 from both sides. Okay. Now, what I do from here is I put myself a blank. If I add something to one side, I have to add it to the other. I'm going to set up that blank on both sides. And you're like, Ms. Jungle, that's crazy. Why are you doing that? Okay?
So it doesn't matter if it's like plus or minus?
No matter what, it's going to be plus. And we're going to talk about why in a second here. Okay? Now, remember, my goal is to get something that looks like this. Right? I have to figure out what goes in here, and that'll tell me what number I have to put in that space right there. Does that make sense? Okay. Now I see here that I have a 12x. Okay. And I know for that reason that the number that goes here is half of whatever the coefficient in front of the x is. And I'm going to show you why. Okay. So if I have x plus 6 squared, I'm going to show you. Okay? So if I have x plus 6 squared, remember how I was really, really particular about my language when it came to applying an exponent and not saying distributing? So I can't just distribute the square and say that's x squared plus 36. That's wrong. Because when you square that, it's the same thing as x plus 6 times x plus 6, correct? So this becomes x squared plus 6x plus 6x plus 36. So x squared plus 12x plus 36. Perfect square binomials always have this pattern. Tomas, what's wrong?
Really get what you just did there.
Okay, all I did, do you know FOIL? Did you ever learn FOIL? Maybe you did it like this. Did you do the lattice method?
Yeah.
Okay.
Oh, there we go. Okay.
Same thing.
All right.
Okay? So do you see how I still get x squared plus 12x plus 36? So I know if I have a 12 here and I want a perfect square binomial, then the factors have to have that constant be half of the 12. Because I know these two middle terms, when I do this, are always going to be the same. So if I take this number and divide it by 2, I'm going to get the number I need to get that 12. Does that make sense? Yeah, Shania?
So is that number that you're putting in 36?
Right, so now that number that I'm putting in has to be 36 because I know that's how this factors. Does that make sense? No? Why not? What about it doesn't make sense, I should say?
Well, the 6. Yeah.
So do you see how when I multiply it out, I get the 6x, like this part matches, right? Okay, Christina, do you see how this part matches when I multiply x plus 6 and x plus 6?
Yeah. So does it always have to be a 6?
No,
it's always half of it?
It's always half of that. Okay?
Yeah, so it's always, no matter what. It's
No matter what, it's half the middle term. Okay?
Wow.
And this is why. Because I know when I actually use the lattice method, these two have to be the same. Does that make sense, Christina?
Yeah.
Now that being said, that means I also am going to have that number squared as my constant. Okay? So because I put 6 here, the blank has to be 36. Because these two things are equal. Okay, that's how I can go from this step to this step. This, you don't have to. You could say, okay, it's 12 divided by 2 is 6. This is x plus 6, so this is 36. Done. Okay? You know me. I always have to explain the why. Okay? All right, so what does this side become? Negative 32 and 36 is 4. Okay? Now I'm going to take the square root of both sides. Now remember, the square root of 4 is not just 2. It's also what? Negative 2. So I know that I have x plus 6 is equal to 2, or, and in your online program, you could think of it as a comma, x plus 6 is equal to negative 4. Or sorry, negative 2. Woo! Nice jungle. Okay, we're okay? So x is equal to negative 4, and x is equal to negative 8.
Yeah.
How did I get that? Because I subtracted 6 from both sides. Negative 2 minus 6. Okay? So I have x equals negative 4 and x equals negative 8 as my solution to this particular equation. Okay? Now, just to kind of recap, this is one method. I also could have factored this as x plus 4 times x plus 8 and gotten negative 4 and negative 8. I also could have graphed this. And it was what, plus 30, right? And notice I got the same negative 4 and negative 8.
That's way easier.
Okay? But now we have how many methods?
3.
3. Okay, super handy to have 3 methods. The other piece, you know how I got this right here?
How would you do it if the x, it was like there was an 8 before? Like
This?
8x squared.
8x squared, you wouldn't use completing the square. You'd have to divide everything out by 8 first.
Oh.
And that could get messy. Okay, and that's why we have multiple methods. Maybe if I have a coefficient of 8 in front, this is not a good method to use. Okay, the other advantage of this is, let's say instead this was y. Okay, well we got this is equal to 4, right? So I could say x plus 6 squared minus 4 is equal to y, correct? Now I have vertex form. So I could do this instead of using the formula. Remember the vertex formula, negative b over 2a? Instead of using that formula, I could just do completing the square to get my vertex form. That's it. I mean, like, it's all connected, okay? Does that make sense? Would we like to see one more example?
Yeah.
Okay. All right. So x squared plus 16x equals 36. Notice they already have it moved over to the other side for me. Now I'm going to leave myself a little bit of space, right? Because what am I going to put in right now? Plus blank, plus blank. So remember, my goal is to get this format. So Tomas says it's going to be x plus 8. Do we agree with Tomas? Yeah, why?
Half is half.
Because the half is 16. What goes in the blank? 64. Why 64? Because it's 8 times. Right. If I was going to actually FOIL this all out or multiply it all out, I get x squared plus 16x plus 64. So then this is equal to
64.
or 100. Or 100. All right. And then what do I do? I take the square root of both sides now. What am I going to make sure I keep in mind? Good. It could be a positive or negative 10. Okay? So I know that x plus 8 is equal to 10, or x plus 8 is equal to negative 10. Christina, what do I do now? I know. You're a good person to tell me about my pace. What do I do now, Christina?
No, I was like copying it down.
Okay, what do I do now?
Don't you subtract the 8?
I do subtract the 8. X is equal to
2, or x is equal to -18.
Okay. I could also have solved this how? Right, graphing, or I could have said x minus 2 and x plus 18 equals 0. Okay? Because I would have moved the 36 over and done that factor.
Or you could have just grabbed
Or I could have just graphed it too.
and then
To find the, well, you're finding the x-intercepts.
yeah, but then
You'd find the x-intercepts. Do you know what I mean by x-intercepts, Clara?
now can you show us if there is like a 10x squared? Like if there is a number before?
I don't want to go there today. Okay? That's more of like a pre-calc skill. Okay? So basically,
we're always gonna just have an x squared.
for our purposes for right now, yeah, it's just going to be an x squared. Okay? Any questions on this? Okay, now if I were to label my steps, like where would you call our steps? Like what would our steps be? Okay, so 1 would be the setup. Right? Maybe I get everything ready to go in the right format. 2 would be what? Find the constant. What would you call step 3? Take the root? Or do you want like the format? Find the constant, step 3, format. Step 4, root with plus or minus. And 5 would be solve. Does that sound about right?
Yeah.
Okay, so we're taking a look at our objective for today. Let me pull this right back up. Okay, we're making sure we know how to use the technique of completing the square. We define what it is, right? Something utilizing that particular format. We've got some steps we're going to have on the board here. Does anybody also notice how this is base power just like we had in Unit 5? Do you guys see that? What's the little bit of difference with from Unit 5?
We have to divide it. We just
considering the positive and negative solutions would be something that you have to be more careful with in this unit than you did in Unit 5. Okay? Does that make sense? All right, so I'm going to stop this.